Verifying trigonometric identities is a process of proving that the left-hand side of the equation is equal to the right-hand side. There are many ways you can go about verifying trig identities, but there are some guidelines for proving trig identities that can help start you off, especially if you don't know where to go. First, start with one side, meaning pick one side of the equation and write it down. You're trying to transform it into the other side, and while it may seem counterintuitive, always start with the more complicated side as it gives you more options to work with. 2. Use known identities. Use algebra and the identities you know to change the side you are starting with, and then you want to make it look like the other. Use algebraic or trigonometric manipulations to do that. And 3, most importantly, convert to sines and cosines. If you get stuck, try and write all functions in terms of sines and cosines. I like to do that first, but if you don't want to do it first, that's fine as well. Whatever works for you. So let's look at some examples. So first off we have here is sine squared alpha plus cosine squared alpha plus tangent squared alpha equals secant squared alpha. So I'm going to take the side with the most, which is the left-hand side, and I'm going to work with that. So sine squared alpha plus cosine squared alpha plus tangent squared alpha. So we have all of this. What can I do? Well, the first thing I can see is that I can group sine squared alpha plus cosine squared alpha. And I know from my Pythagorean theorem identity is that sine squared plus cosine squared equals 1. So automatically I can say that this is 1 plus tangent squared alpha. Now where do I go from here? Well, again, remember sine squared plus cosine squared equals 1. But if you were to do some algebra manipulation, let's say you, I don't know, divide all three parts of this equation by cosine squared. If you divide sine squared by cosine squared, you're going to end up with tangent squared. Cosine squared divided by cosine squared is going to give you 1. 1 over cosine squared is going to give you secant squared. So 1 plus tangent squared alpha is nothing more than saying that it is secant squared alpha. And look at that. It proves that the identity is true because it equals the right-hand side. So again, using the Pythagorean identity, sine squared plus cosine squared equals 1, you can do manipulations on it to get another identity, this time involving tangent and secant. And if you divide both sides by sine instead, you're going to end up with cotangent and cosecant instead. How about this one here? Secant x plus cosecant x over tangent x plus cotangent x equals sine x plus cosine x. So a lot going on here. Again, start with the side with the most, which is going to be the left-hand side, and try and manipulate it down. So secant x plus cosecant x over tangent x plus cotangent x. So I don't like what I have here, nothing to the second power. I'm going to turn everything into sines and cosines. So 1 over cosine x plus 1 over sine x all over sine x over cosine x plus cosine x over sine x. I got a lot of fractions roaming around here, so I'm going to get one fraction for the top and one fraction for the bottom. So the top is going to end up giving me sine x plus cosine x all over sine x cosine x. And in the bottom, I'm going to get sine squared x plus cosine squared x all over sine x, not plus, sine x cosine x. Now both have the same denominator, sine x, cosine x, so I can just get rid of those automatically. And I'm going to end up with sine x plus cosine x over sine squared x plus cosine squared x. And again, I think back to my Pythagorean identity, especially the one I used up top. Sine squared plus cosine squared equals 1. So sine x plus cosine x over 1 We don't really need the over 1, so we can get rid of that and just say it's sine x plus cosine x, which happens again to equal the right-hand side, again proving or validating the trig identity. Again, use sines and cosines, use algebra manipulation, use trigonometric manipulation to get it to the form you want, and then a lot of this stuff is just plug and play and just play around with it until eventually it works. There's going to be a lot of trial and error, but that's just the way it goes.